Hello and welcome to the third of 5 short videos that I'm hoping will help you to be prepared for the start of A-level chemistry. And this video is on moles. Now moles is a measurement that we use in chemistry, and it does make calculations a lot easier. What do you need to know about moles? A mole is an amount of substance. So if you take 12 grams of carbon, then that is 1 mole. 23 grams of sodium is 1 mole. If you take in a beaker 32.1 grams of sulfur, then that equals 1 mole. And what do all these numbers have in common? So they are all the relative atomic mass of the element in grams, which you just find from the periodic table. So the relative atomic mass in grams equals 1 mole. And also, if you have 18 grams of water, that equals 1 mole. 58.5 grams of sodium chloride equals 1 mole. And that's the relative molecular mass, or the relative formula mass in grams equals 1 mole. And just to recall how to work out the relative molecular mass, so let's say of water, you add up the relative atomic masses. So the relative atomic mass, which you find from the periodic table, of hydrogen is 1, and there are 2 hydrogens, and the relative atomic mass of oxygen is 16, so that gives you a relative molecular mass of 18. Therefore, the relative atomic mass or the relative molecular mass in grams equals 1 mole. Another important fact that you need to know about moles is that a mole contains 6.02 times 10 to the 23 particles. So if you have 12 grams of carbon, that's 1 mole. That means there are 6.02 times 10 to the 23 carbon atoms. If you have 18 grams of water, that's 1 mole. That means there are 6.02 times 10 to the 23 water molecules. If you have an ionic compound like sodium chloride, 58.5 grams of sodium chloride is 1 mole, which means that there are 6.02 times 10 to the 23 sodium ions, and that same number of chloride ions as well. And this number is called the Avogadro constant. So let's have a go at an example question. So how many hydroxide ions are there in 1 mole of magnesium hydroxide? So if you have 1 mole, 1 magnesium hydroxide, then there are 2 hydroxide ions in each mole. So you have 1 mole of magnesium hydroxide, and there are 2 moles of hydroxide ions. 1 mole is 6.02 times 10 to the 23. Therefore, 2 moles is 2 times 6.02 times 10 to the 23. And that equals 1.2 times 10 to the 24 hydroxide ions. Now, when you're doing moles calculations, it really does help if you can recall the 3 moles equations. So if you're doing a calculation with a mass, then it is mass in grams over relative atomic mass or relative molecular mass. Sometimes they give you the mass in kilograms and you need to convert it into grams. If you are have an equation, a calculation with solutions, then you need moles equals concentration times volume. If the volume is in decimeter cubed, or if it's in centimeters cubed, you need to divide by 1,000. That's because 1 decimeter cubed equals 1,000 centimeters cubed. And that's why you need to divide by 1,000. And then finally, if you have volume of a gas, then the equation moles equals volume of a gas divided by 24, or if it's in centimeters cubed, it'll be divided by 24,000. So let's have a go at a couple of questions in order to see this in practice. Now, whenever you have a moles question like this question here, the very first thing you should do is write the balanced chemical equation. And so many students start a moles calculation without writing the balanced chemical equation, and then they make a silly mistake and they don't get the marks. So that's what we're going to do first. We're going to write the balanced chemical equation. So we've got magnesium ribbon, and we're going to put state symbols in because it's good practice, and it reacts with hydrochloric acid. So it reacts with hydrochloric acid, and that's going to make, now hopefully you watched the writing chemical equations video, and so you should know it forms magnesium chloride, salt, plus hydrogen gas, and we just need to balance the equation. Now it's a really good idea to write the key bits of information underneath each item in the equation. So there's 4.80 grams of magnesium, reacts with excess hydrochloric acid, which means too much hydrochloric acid, and you have to calculate the volume of gas produced. Okay, so we need to use those three equations in order to work this out. We've got a mass of magnesium. So we've got a mass of magnesium, so we're going to use the equation moles equals mass over relative atomic mass or relative molecular mass. So we've got 4.80 grams. Find the relative atomic mass on the periodic table. Make sure that you are using the A-level periodic table, and it's 24.3. And so you do that calculation, and you should get moles 0.198 moles. Now I'm just going to write down three significant figures because the question is using three significant figures. But what you should be doing is carrying the whole of the calculator number through the whole of the calculation. Right, that's the moles of magnesium. So what's the moles of hydrogen going to be? One magnesium makes one hydrogen. So the moles is exactly the same. 1 makes 1. So the moles, the ratio is the same, so the moles is the same. And that's the moles of hydrogen. So we need to find the volume of hydrogen. So we've got the moles of hydrogen. And the equation is the volume of gas equation. Volume over 24. That's if we're doing it in decimeter cubed. And because the 24 is on the bottom, we're going to bring it up and times it. So it's going to be 25. We're just going to 24. Sorry, we're just going to rearrange the equation. 24 times 0.198, and that equals. I'm going to keep three significant figures. But remember what I said about carrying the whole number through your calculation, and don't forget your units, decimeter cubed. All right, let's try another question. Okay, it's a good idea maybe to pause the video, have a go at this yourself to see if you get the same answer. But the first thing we're going to do is we're going to write the equation. So we have got calcium solid, and that is reacting with nitric acid. And again, you need to practice writing these equations, and it's going to make the salt calcium nitrate and hydrogen gas. We just need to balance the equation, and there we go. Okay, so let's write the key information underneath each item. We need to find the volume. That's what it's asking you to find. We've got the concentration. Let's just recall what concentration is. So this concentration, this means that there is 0.2 moles of acid, 0.2 moles of acid dissolved in 1 decimeter cubed. That is what it means with that concentration. And we have got 0.385 grams of calcium. So we've got a mass of calcium. The first thing we can do is work out the moles. So divide it by the relative atomic mass, and that's going to equal, to give the moles, that equals 9.60 times 10 to the minus 3 moles. That's the amount of calcium. So what's the moles, the amount of nitric acid, going to be? Well, the ratio is 1 to 2. So if there's that many moles of calcium, the moles of nitric acid is going to be 2 times 2 times that moles, and that's going to be the moles of nitric acid. We need to find the volume, so we've got the concentration times the volume, and it says find the volume in centimeters cubed, so we need to divide by 1,000. Okay, so let's rearrange this equation. I'm just going to make a little bit of room and use a different color so it stands out. So the volume is going to be the moles times 1,000, because it's dividing on that side, and then divided by 0.2. And when you do that, your answer, if we're keeping to the 3 significant figures, your answer is going to be 96.0. Don't forget your units, centimeters cubed is your answer. Okay, and one more example, and there is a worksheet. I'm going to make a worksheet to accompany this video so you can practice more of these questions. So again, the first thing you want to do is write the equation, the balanced chemical equation. So sodium oxide plus hydrochloric acid, and that's going to make the salt sodium chloride plus water. And we just need to balance. There are 2 sodiums, so we need 2 sodiums there, 2 chlorines, we need 2 there. Let's write the key information underneath each item. So you've got 12.5 centimeters cubed of acid. We've got 0.1 concentration, and the job is to find the mass. Okay, so the first thing we're going to do, we've got a volume and a concentration, so we can find the moles of acid, the amount of acid. So volume is in centimeters cubed times the concentration divided by 1,000. And that gives us a moles of 1.25 times 10 to the minus 3 moles. And then we look at the ratio. The ratio is 1 to 2. So the moles of sodium oxide is half, 1 to 2. The moles of sodium oxide is half. So we're going to take the moles and we're going to halve in order to get the moles of sodium oxide. So that's going to be 6.25. I hope you're also doing this on your calculator, and that's the moles of sodium oxide. Now that we've got the moles of sodium oxide, we can work out the mass of sodium oxide, because moles equals mass in grams over the mR. So the mass over the mR, and the mR of sodium oxide is 62. And therefore we need to take the 62 up and times it because it's dividing it. So the mass of sodium oxide is going to be 62 times the moles, making sure to carry the whole calculator number through your answer, and the answer to 3 significant figures is going to be 0.0388 grams. Okay, so please don't worry about this. It is just practice, and like I said, there is a worksheet accompanying this video as well, and the next video is going to be on bonding and structure. Thank you. Bye.